So we were talking about why we see relationships in scatter plots, so let's just go for it. All right, this is just going to wrap up how the quiz went and what we need to know. First of all, we need to look at limitations for correlation, coefficient of determination, and least squares regression line. But I want to throw in my own little piece of advice, and that is, if you don't know the difference between r and r squared, figure it out, okay? Because it's not any kind of time to go into this test on Tuesday not knowing. If you don't know and you can't figure it out, ask me, ask somebody. Most of us have a handle on it. We'll help you. All right. These three things are only available for linear relationships. So don't waste your time. If you graph, that's what you should be doing first thing once you enter data, is graph first. And if you've got a curved relationship visually, those three things are not appropriate. In fact, you're out. You don't have to keep going. You need other tools to handle curved relationships, and we just don't have those yet. We've already seen that r squared, and least squared regression line can be influenced by extremes, so those things are non-resistant, all three of them. And one thing I kind of surprised my classes today was I asked them if you had on your quiz any outliers, and it turned out that yeah, you did, and very few people commented on it. So it's strength, direction, form, and extremes. Don't forget to look for them because they have a big impact on things. Okay, another thing that was on your quiz. Do you remember a problem that called on you to do a prediction and it was extrapolation? You may not remember because very few people caught it. This is predicting outside the domain of X, so if you're asked to do a prediction on a value that's higher than your highest X or lower than your lowest X, you shouldn't be doing it. If you do it, fine, but say that the whole thing is inappropriate and it's unreliable. Okay, so there's that. Lurking variables, they're always a concern. We'll cover those a little more as we get into this presentation. And here's an interesting thing. And we're actually going to run into this on our horsepower lab because we have to get 3 times running up the stairs and average them. And this is telling us, yeah, we probably shouldn't do that. Because really, when you combine info from many individuals into one, you lose any kind of variability that you would have had with each individual data item. And so you end up with correlations that are maybe unusually high or are too high. So watch out for that. All right, so here is our first reason why an association could happen. We might see X and Y behaving quite well related with each other, and we might think that X causes Y, and maybe it does. It could, at least for the most part. So like in the summertime, when we had those super hot days and the governing body for the power grid said, we really need you to raise your temperature a couple of degrees because we're going to blow out the grid. Otherwise, that's, temperature going down, temperature going up will cause increased power consumption as we struggle to remain comfortable. All right, common response. That term there is very often found. This is when we look at X and Y and they're behaving very well together. We think X causes Y, but really somewhere below this lurks Z. We may know it, we may not be able to know it, which is driving them both. And so really X and Y don't have anything whatsoever to do with each other. They're just responding to a third variable. And here's a good example. So if you look at this data set, this is from Civil War time to the turn of the century. It's New England. I believe these are Methodist ministers. And over time, they're becoming more and more frequent. Also, this is the rum that's imported into Boston, probably a lot of which is consumed in New England, and it's going up too. In fact, these two things are so perfectly related that your correlation is this. And your r squared essentially goes to rounding. It's going to be 1. So all of the variation in the barrels of rum imported can be explained by the growth in the number of ministers. So Obviously, that must mean that as your religious environment becomes more and more developed or bigger, then there's a need to drink more. Or maybe not. Let's see. Could there be anything that would be driving them both? Most classes figured it out. It is, right? That's what we're comparing. That's how well they're related. And the variable that we picked that was driving both of them was just the population's getting bigger. So there's probably a whole host of variables that are growing in a very, lockstep manner with each other. So it's just because the population is bigger, there's a greater need for more of these items. So that's what's going on. All right, this third one may be a little tougher to understand, and it's really tough to actually analyze and drill deep down to get some meaning out of. And this is where we think X causes Y. And to a certain extent, X does cause Y. But what about if X causes a portion of Y, but Z is really driving Y as well? All right, that's a problem, because at this point, let's just say you've got, there's an example on the next page. I will save it. But yeah, there's some kind of extra variable that's influencing Y apart from X, and we just are not studying it, so we may not actually even know. So it's the effect on Y of the explanatory variable X is hopelessly mixed up with the effect on Y of other variables. So an example of that, you would think that calorie consumption would be related to a person's body mass index. That's how much they weigh. The greater the calories, the greater the body mass index. But is it not true that oftentimes people's physical makeup is genetically determined? So this could be confounding. How much of this body mass index is really accountable because of the genetics or because of the calories? We would never know. So that's confounding. That's where you just don't know things. All right, keep in mind that association does not imply causation. Just like with the ministers in the barrel of rum, that was a strong correlation. It was perfect. But the two had nothing in common other than being driven by a third variable. So it's not good evidence, even if the association is good and strong, that changes in X cause changes in Y. You can't get a good, complete explanation just from looking at those two things in a scatter plot. All right, the best way to get evidence that X causes Y is to do an experiment, because in an experiment you actually impose control on all other variables other than the explanatory variable that you're interested in. And if you see an effect from Y after you run the experiment, the only thing that could have created that effect would have been whatever you had input as an X value or explanatory into that experiment. You've controlled for all the other ones, so they can't be making Y change. X is the only thing. So that's causation right there. And one thing that we talked about was kind of a dramatic thing that's taken place mostly in my lifetime, and that's going after the tobacco industry and getting them to admit that smoking causes cancer. Because early on, when it was pretty well suspected that that was the case, the argument was presented to the tobacco companies. They said, well, there may be a relationship, but we don't believe that smoking causes cancer. There are other things that can cause it. And the only way you could beat them at that game was to do an experiment. But think about an experiment. What do? Take like 55-year-olds and randomly assign 25 of each to two groups, one that smokes and one that doesn't. We follow them for 40 years. I mean, that's impossible to do. It's unethical. It can't be done. So what finally flipped this controversy in favor of what we all know to be true, that smoking is a leading cause of cancer? Lung cancer. Oh, lots of cancers, really. And that's really, one person brought up animal testing, and that's probably very true. An experiment with animals, that's not a very popular thing these days, but it has been done. But really, what we ended up really flipping this into the favor of those folks wanting to limit smoking was just the preponderance of evidence. There was so much evidence. It's like, come on, man, look. Like 60% of these smokers are getting cancer, and all the non-smokers, maybe 2% of them are getting lung cancer. It's like, you can't deny this. And finally, the preponderance of evidence won out. All right, in case you're a little bit, dizzy with confounding versus lurking, I put this up here, but my explanation went as follows. Let's just say you're taking a test, and you're in a room, maybe like our classroom, and you've got the color of the walls, you've got the temperature in the room, you've got the amount of lighting, you've got somebody out in the outside with a jackhammer making a lot of noise, and you've got somebody next to you who's coughing and sneezing, right? Well, all of those are lurking variables, among many. There's probably an infinite number that we could identify, or at least a whole lot. But maybe the lighting is fine and that's not changing anything. Or the wall color, you don't even notice it. Or the temperature in the room is great, but you're being distracted by the person with the sneezing and the coughing and the person with the jackhammer. Those could confound what happens with your test score. So while all of them are lurking, only the ones that impact your response variable are going to be the confounding ones. And how much those things contribute, who knows? But, so see the difference? It's like confounding is sort of a subset of lurking. They're the ones that are active, and the other ones are just passive. All right, so we ran through these examples. High positive association, nations with many TV sets have higher life expectancies, so shouldn't we ship TVs off to third world countries? And we thought that would be a great idea if you're in a third world country to get a free TV, but lengthening their life, I think that has more to do with the money that people have at their disposal. And in first world countries, we have a lot, and in third world countries, not so much. All right, this is a thing. People who use artificial sweeteners in place of sugar tend to be heavier than people who use sugar. Does artificial sweetener cause weight gain? Well, maybe and maybe not. All right, there is some scientific research that claims that when you eat a sweetener, it activates your hunger, or your body's expecting calories to go with it, and when it doesn't get it, it craves them. So maybe. But then again, it could be that people get something that is low sugar, which means less calories, and they think, well, there's no sugar or extra calories in this. I'm just going to eat as much as I want. Or some people just said the heavier people tend to eat more, whether it's sweet or not. So all of those seem to be reasonable. This one is already answered. Again, if you own 2 cars, you tend to live longer than people who only own 1 car. Owning 3 is even better. So I'm going to go out and get me 2 cars. I just decided. What might explain the association? Again, it's money, just like in the previous one. Children who watch many hours of TV get lower grades on average than those who watch less TV. Why does this fact not show that watching TV causes low grades? Well, I mean, if you figure that a kid is watching TV to the exclusion of everything else, that may contribute to a lack of study. But I posed, the question, what happens if you just, pull the plug on the TV? What's the kid going to do? And most people said he's going to go fire up his iPad, or go on the computer, or get on the phone, or even read a book in a kind of passive-aggressive way. So it might be a kid's attitude is what's causing the low grades, and the TV is just a symptom of the attitude. All right, data show that married men and men who are divorced or widowed earn more than men who have never been married. If you want to make more money, should you get married? No, not necessarily. Although I do struggle with this one. I had people say yes, because you're motivated to earn more money because women demand it of men. And this is not me talking. This was a girl who came up with this. So whatever. But I think the most widely accepted one was that it's more a factor of age. You know, older people tend to be married and they're also at a track in their life where they're making more money. I don't know. I'm not sure about that one. This one I am sure about, and this is one we ought to just linger on for a moment. So high school students who take the SAT, they enroll in an SAT coaching course, which I understand is expensive. They take the SAT again and raise their math score from an average of 521 to 561. Well, that's going to make mom and dad happy because, you know, forking over the money for this isn't cheap. But can this increase be attributed entirely to taking the course? Well, there is one main thing that's happening here. And let me just ask you, if you take a test and get a score, and then you take the test again, won't you just get a higher score because you took the first one? Like, isn't there some kind of a learning curve that you get from having already experienced it? You see the nature of the questions, you get the timing down better, all these kind of things, right? So it's the learning effect from having taken it the first time. I think maybe the training helped, but this is a possible, you know, alternative excuse. So your homework is review number 1. Answers are posted. Review number 2. Answers are posted. That's going to be assigned tomorrow. And there's actually a third review up on the reprints on Canvas, and the answers are with it. I am not asking you to do that. It's just there for people who would like the extra practice. So we are kind of on our, you know, countdown to our test next Tuesday. Remember, tomorrow we're racing the stairs, and so bring appropriate shoes, get a timer app on your phone, and we will do that. And yeah, so there you go. I am going to now close out, and I appreciate that you watched. So bye-bye.